There are a lot of scary and unexplained things out there in the universe, including some terrifying worlds with conditions beyond our imagination. From a terrifying world that rains molten glass, and a world where ice on its surface is actually burning, to another planet that's a big ball of lightning. We put together some of the most nightmarish worlds out there in the cosmos for your enjoyment. Are you afraid of the dark? Then TRES-2b, 702 light-years from Earth, will terrify anyone who suffers from being trapped in complete darkness. This gas giant, as big as Jupiter, is blacker than coal and reflects just 1% of the sunlight that hits it. And it's a big mystery of what's causing it to be so dark. TRES-2b orbits only 4.8 million kilometers, or just 3 million miles from its star, which heats the planet to a toasty 982 degrees centigrade. But researchers found it's actually not completely pitch black, but it's so hot that it emits a faint red glow like burning embers in a campfire. But this isn't the only planet with crazy storms. There's a distant Neptune-sized gas giant named HAT-P11b that's about 122 light-years away, which has lightning storms that would get even Dr. Frankenstein excited. But that's not all. Radio telescopes picked up an eerie signal coming from the planet, and astronomers think these radio waves are coming from these blindingly intense lightning storms. Just how scary and intense? Imagine a lightning storm on Earth that managed to cover the entire planet. And even then, it would only produce a signal about 1% as strong as the one coming from HAT-P11b. If the exoplanet's lightning were more similar to Earth's, it would take over 3 million flashes per square kilometer every hour to produce the radio signals that researchers recorded from HAT-P11b. Speaking of Frankenstein, NASA calls this planet the ultimate Frankenstein creation, but we're not exactly sure why. It was given the name Wasp-12b and will be destroyed by its parent star in just 10 million years, a fleeting moment in space-time. The star that Wasp-12b orbits is so hot that it's tearing apart the planet's atmosphere, which is composed of atomic hydrogen and helium. Because the planet is tidal-locked and combined with the extreme gravitational pull from its star, it causes massive tidal forces that are stretching the planet into the shape of an egg. The temperature on this sizzling gas giant that's twice the size of Jupiter is a scorching 2,210 degrees centigrade, and its surface is said to be as black as fresh asphalt. Not a pretty place at all. This next planet lies 30 light-years away from Earth and has one of the most bizarre and unimaginable conditions. It's called GJ436b, and it sits just 6.4 million kilometers from its star. Compare that to the planet Mercury, which is 57.9 kilometers away from our Sun. Its temperature is around 438 degrees centigrade, which is certainly hot enough to evaporate water. But the really strange thing is that the planet's water remains in solid form. Like something right out of a science fiction horror movie, GJ436b is a planet of burning ice. You're probably asking yourself right now, how is it possible that ice can burn? Well, it's not the kind of ice we have here on Earth, but something exotic called Ice 7, which has a denser and more crystalline structure. Scientists believe this ice formed due to the strong gravitational force at the planet's core when temperatures are extremely high. Strange things happen in the Twilight Zone, but even stranger than that is the planet named 55 Cancri E, or otherwise known as Jensen. The planet sits about 40 light-years away from Earth and is made up of 1/3 diamond. This is most likely due to the planet's atmosphere that is mostly carbon, allowing heat and pressure from both its star and its interior that compresses the planet's mass into diamond. Someone actually valued the planet at $26.9 nonillion. It's so close to its star that water cannot exist in a liquid state, but instead in what's called supercritical state, a strange behavior where the water is between a liquid and a gas. Whether on the incredibly hot side of the planet where temperatures soar to a crispy 2,204.4 degrees centigrade, or in its dark twilight zone, there is no chance that anything could survive. And for added spookiness, The Hubble telescope just detected what could be hydrogen cyanide oozing out from below the planet's surface, resulting in a superheated poisonous fluid covering some of its surface. Now imagine for a moment if the sun's light and heat were amplified 1,000 times on Earth for just one day, and then went back to normal temperatures again. Well, there is actually a planet just like this out there labeled HD 8606b that's part of a binary star system. It has one of the most elongated orbits of any exoplanet yet found. HD 8606b spends most of its time around 127.1 million kilometers away from its star. But every 111 days, the planet whips around its star at just 4.5 million kilometers away. The results of the planet getting so close to its star so quickly causes temperatures to skyrocket from the already hot 526 degrees centigrade to 1226 degrees centigrade in just 6 hours. All that energy creates one of the fiercest storms in the galaxy, with shrieking winds at over 702 kilometers per hour around the planet for a few hours, and then dying out as the planet swings back out into the darkness of space. HD 189733b is a gas giant located about 63 light-years away from Earth. Its atmosphere has a deep blue azure color due to the silicate particles in its atmosphere. So what's so scary about it? First of all, wind speeds on this planet can reach 8,690 kilometers per hour. That's 2 kilometers per second, or 7 times the speed of sound. It's also very hot, as temperatures can reach over 900 degrees centigrade. But you want to know what's really scary? It literally rains molten glass sideways on the planet. And along with those brutally fast winds, anything caught in such a storm would likely be incinerated and sliced to shreds by the molten glass rain. While we're on the subject of Jupiter, researchers have recently found something weird happening in the gas giant's iconic Great Red Spot storm. This is the biggest and scariest storm in our solar system, and recently it just got wilder. The winds in Jupiter's Great Red Spot are getting faster, and astronomers were surprised because nobody has ever seen anything like this before. The massive storm, which is a vortex bigger than the Earth itself, has ominous red clouds that spin counterclockwise at speeds in excess of 643 kilometers per hour. Zooming back out into the universe at 489 light-years from Earth, there sits a hellish world. This is Corot 7b, which is 1.5 times the size of Earth, but sits 60 times closer to its parent star than we do from our Sun. Just imagine for a moment the Sun 360 times larger in the sky. On the planet's tidally locked day side, it can reach a blistering 2,593 degrees centigrade, which is hot enough to melt and vaporize solid rock. Some researchers say that Corot 7b could also have boiling oceans and lava. However, the other half of the planet facing away from the star is a bitter cold that can reach a frosty minus 235.6 degrees centigrade. If you've ever been lucky enough to see a blood moon in Earth's skies, then just imagine a planet with not one but 6 bright red blood moons in its sky. We're talking about the planet Trappist 1b. This planet is thought to be a rocky world like planet Earth, but has an extreme temperature of 1,220 degrees centigrade. Those moons we're talking about are actually the other 6 large worlds in the Trappist System that reflect light, and 3 of those lie in the system's habitable zone. But from the surface of Trappist 1b, they would look like moons in the sky. 2 of those planets are thought to have liquid water, and Trappist 1b would have water in vapor form. It's said that some of these planets could hold some kind of alien life. By the way, we've got a really great video on the Trappist System. If you haven't seen it yet, check it out. What video of terrifying planets would be complete without our solar system's own Venus? They say that the planet could pass for Earth's evil twin. It's about the same size, has roughly the same rocky layers, and billions of years ago, it could have been habitable. However, a runaway greenhouse effect turned Venus into a hellish world where the atmosphere would crush you and is hot enough to melt lead. Not only that, but it actually rains big steaming drops of sulfuric acid. From space, Venus looks innocent enough, but at the surface, it's a scene from a nightmare. Just enough sunlight filters through the thick atmosphere that casts a dull orange glow over a jagged volcanic landscape. And that atmosphere bears down with a pressure 90 times greater than on Earth, and the air is a blistering 460 degrees centigrade. Stars are born in clouds of gas and dust called nebulae. As gas molecules and dust particles come together, they collapse under their own gravity and heat up to form a protostar, the initial phase of a star's evolution. As a hot core forms and gathers material, it continues to heat up, and once it reaches about 15 million degrees Celsius, a star enters its main sequence phase and nuclear fusion begins. That's how a star will spend about 90% of its time. Scientists think that to sustain nuclear fusion, a star can be no smaller than 8.7% the diameter of our Sun, which is roughly 1.39 million kilometers. With a bit of calculations, these 8.7% translate into about 120,000 kilometers. But that's still a bit smaller than Jupiter, which is, like most stars, made of hydrogen and helium. So why isn't it a star? Jupiter just isn't massive and dense enough. It lacks internal pressure and temperature to sustain nuclear fusion. Generally, the more mass a star has, the shorter its lifespan. A star the size of our Sun will stick around for roughly 10 billion years, but one that's 10 times more massive than that would only live for about 20 million years. But what happens after that? Approximately 97% of stars will become white dwarfs. And just recently, scientists discovered a miniature white dwarf around 4,300 kilometers wide and 45,700 degrees Celsius in temperature. That's just a bit larger than our moon and is roughly the distance from Los Angeles to Washington, D.C. But don't be misled by the tiny size of this star. It has 35% more mass than our yellow dwarf sun. In fact, 1 teaspoon of matter from a white dwarf star would weigh as much as a 5.5-ton elephant on Earth. This makes it the smallest and yet the most massive white dwarf discovered so far. This white dwarf also makes a full 360-degree rotation in just 7 minutes, which is 200 times faster than our planet rotates. But could we survive living near a white dwarf? As our Sun will eventually become a red giant when all of its fuel is used up, it'll transform into a white dwarf. But let's say, for example, that planet Earth was placed in the habitable zone of a white dwarf. Generally, white dwarfs are bright enough to have habitable zones around them, but too dim to extend the habitable zone far enough to where we are now from our Sun. A habitable zone around a white dwarf begins at about 1/100th the distance that our planet is to the Sun, and that's quite dangerous because of the gravitational force. That gravitational force would tidally lock our planet. Although a tidally locked planet would look interesting because of the permanent night side and day side, the gravitational pull of a dead star will heat and flex Earth a lot. The closest planets, Mercury and Venus, will be, most probably, obliterated. But that's just the beginning. Over time, white dwarfs cool and emit less light, thus shifting their habitable zone closer and closer to a dead star. This means all the water on Earth would freeze, and with less light, we'd be bathed in high-energy radiation. If that happens, our planet would become more like Venus, with an atmosphere filled with carbon dioxide. Now, what about the stars that are bigger than white dwarfs, and how do we even measure the size of a star? It turns out that scientists can tell how big a star is by knowing its surface temperature and luminosity, which is the energy that a star emits. They've even come up with a special diagram that can predict the size of a star depending on the above-mentioned criteria. Although we think something's hot if it's orange or red, with stars, it works the other way round. The hottest stars out there have blue hues, while cooler stars appear to be red. And this representative of a very rare stellar class of stars is just an example of this rule. It's one of the hottest stars ever discovered. With a radius half that of our Sun, the surface temperature of WR102 is 35 times hotter, and it's got a blue color. But that's still quite smaller than our Sun, and the universe has a lot more stars that are both bigger and more interesting. HD 140283, or Methuselah, is a star that's 1.7 times larger than our Sun. It also has a mass roughly 0.8 solar masses and is about 5 times more luminous than our star. Methuselah is one of the oldest yellow subgiants that we've ever discovered. In fact, it's so ancient that scientists' initial calculations showed it was 16 billion years old, which is odd if the universe is only 13.8 billion years old. But even according to recently revised estimates, this star still seems to have been born shortly after the universe itself. The next star is just a toddler compared to the previous old-timer, but it has some other features that make it stand out. R136A1 is about 30 times our Sun's radius, but it's one of the brightest stars out there. If our Sun was replaced by this star, you probably wouldn't be able to go out without high-quality sunglasses on a sunny day. Breaking the earlier accepted limit of 150 solar masses, this star is a whopping 265 times as massive as our Sun. This number is so huge that it potentially points to the most massive star out there that makes all other known stars pale in comparison. Sadly for this star, due to its extreme mass, temperature, and luminosity, it's doomed to a short life. It's believed to be 1 million years old, and it only has about the same amount of time left before it goes hypernova. R136A1 is a real heavyweight, but its size is still quite tiny compared to a bluish-white supergiant called Alpha Cygni. This monster is roughly 200 times the size and at least 50,000 times more luminous than our Sun. However, Alpha Cygni is just about 19 times as massive as our star, and now imagine how this giant would shine seen from the Earth if it were our Sun. Now let's go to the red supergiants. Meet Antares, a star that's about 680 times the Sun's radius, which is more than 3 times the distance from Earth to the Sun. What this means is that if one day our star was replaced by Antares, our planet and even Mars would have been swallowed by it. But if it was a bit further, the red supergiant would look like a big burning ball of hot plasma, about 1100 times brighter than the Sun. But even a star of this size is nothing compared to the largest one we've been able to detect. Stephenson 218 currently holds the title of the biggest star and is the most luminous red supergiant in the entire universe. The star's radius is nearly 2,150 times the Sun's radius, which is a number that can hardly be grasped by our brains. 3 billion kilometers. Our Sun has a volume of about 1.3 million Earths. Now consider this. Stephenson 218 can fit inside a whopping 10 billion suns. To say it's a huge star is an understatement. Nevertheless, even that is not the limit to how big a star can grow. A hypothetical quasi-star, known as a black hole star, could be much, much larger. Scientists believe these existed at the dawn of the universe, and their size could have been approximately 10 billion kilometers. To give you a bit of perspective, it took nearly 10 years for the New Horizons probe to get close to Pluto, and it would need 5 more years to get out of the quasi-star if it was trapped in one. If one still existed, a quasi-star would produce as much light as a tiny galaxy. That would be a breathtaking phenomenon to contemplate. There are many stars that are much more intriguing than our boring average-sized Sun is. And while it would be a lot more fun to look at those fascinating stars from the Earth, life on our planet is too sensitive for such entertainment. Even the slightest changes in the temperature, radiation, and light could mean an absolute disaster for us. May other stars be 1 billion times brighter, hotter, or bigger, we're still 1 billion times luckier, because we can admire these huge bright monsters through telescopes and live side by side with probably the most favorable star for life. At the beginning of 2022, the Meerkat radio telescope detected a strange and unique signal in the Vela X1 region of the sky. There, 1,300 light-years from Earth, dead neutron stars have found their last resting place. Previously, no pulses from stars or other activity has ever been seen there. So what strange and mysterious object was sending radio signals from a dead part of space? Scientists figured out that it was the neutron star labeled PSR J1191738b. Now, neutron stars are usually spinning really fast. Their rotation periods range between 1.4 milliseconds and 30 seconds. But as they age, their spin slows down. And because of that, they also stop emitting radio bursts. But this star takes as much as 76 seconds to complete one revolution, and still produces pulses. In fact, it has 7 different types of them. Scientists say they've never seen anything like that before. The weakened PSR J1191738b has almost run out of power. Its signals last about 300 milliseconds, which is only 0.5% of the rotation period of the star, so astronomers were lucky that, just for a moment, a radio beam crossed the Earth and they were able to detect it. One idea is that it belongs to a rare class of ultra-long period magnastars, or stars with very strong magnetic fields. If so, the star marks the beginning of a new class of neutron stars, and there could be a whole lot of them out there. But that's not the only star that caught scientists' attention. The blue star S5 HVS1, located only 29,000 light-years from Earth in the constellation of Gliese, is a hypervelocity star, traveling through the Milky Way at a blistering 6 million kilometers per hour. This is roughly 10 times the speed of most stars in our galaxy. So what happened to this star that caused it to be shot across the galaxy at such an incredibly insane speed? By tracing the star S5 HSV1 back in time, researchers have found out the star was ejected from the center of the Milky Way, where the Sagittarius A star black hole sits. This led scientists to a paradoxical thought. Black holes are known to pull celestial bodies inside by their insane gravity once an object is close enough. But, as it turns out, such black hole monsters are also capable of slingshotting celestial bodies through space at incredible speeds. It's possible that something like this could have happened to S5 HSV1. In the past, the star orbited a companion as part of a binary system, but they came too close to Sagittarius A star. The monster black hole captured the companion star with its gravity, and S5 HSV1 was ejected at thousands of kilometers per second. Scientists suggest that the event occurred about 5 million years ago. But there are other stars out there who have insane behavior and defy logic. KIC 8462852, or Tabby Star, from the constellation Cygnus, stands out for its brightness. The star orbits at a distance of about 1,470 light-years from Earth. It's slightly more massive, hotter, and brighter than the Sun. One of the most resonant cosmic stories in recent years has been about Tabby Star. The star became famous in 2015 when the Kepler Space Telescope recorded a decrease in its luminosity over the span of several days. The star's brightness dropped by about 20% and then gradually began to increase. In addition, Tabby Star has consistently had much fainter but long-lasting dimming. Such phenomena have never been observed in other stars slightly larger than the Sun. Believers of extraterrestrial civilizations immediately started talking about the megastructure of a distant, highly evolved civilization. According to their vision, alien intelligent life periodically takes energy from the star for their own needs, and by doing so, dims its light. But recent research by NASA's Spitzer and Swift missions have refuted this idea. Astronomers recorded a smaller dimming of Tabby Star in the infrared spectrum, and aliens certainly had nothing to do with it. Scientists have put forward their hypothesis of the anomalous behavior of the star. The cause of the long and weak periods of low light may lie in uneven movement of the dust cloud around the star. Any object larger than the tiniest dust particle would darken the star when passing in front of it. Researchers say the dust around Tabby Star may not be small enough to evaporate into space, but it's also not large enough to evenly block the entire spectrum of light waves. Particles with a diameter of no more than 1/10,000th of an inch, or about a few micrometers, fit these parameters. The period of rotation of the cloud, according to the researchers' calculations, is about 700 days. So far, they haven't been able to pinpoint the exact source of the dust. It could be dust from a swarm of passing comets, remnants of planetary collisions, or particles of matter from interstellar space. The story isn't over for the legendary Tabby Star, and scientists will continue studying it. Who knows what surprises it may reveal in the future. But stars don't only travel fast or shine bright. There's more. This is the star named HD 140283, located in the constellation Libra, 190 light-years away from Earth. Also known as the Methuselah Star, it was studied in 2000 in an attempt to determine its age. But how is that even possible, given the universe is only 13.8 billion years old? If you'd like to hear the full story about this star, let us know in the comments. Something strange is also happening to another star in the Milky Way. Using the ALMA telescope, scientists have discovered a debris disk surrounding the star. Generally, it's not uncommon for stars to have debris left from the formation of their systems orbiting them, but no other star has a debris disk with such a complicated structure. HD 53143 is a yellow dwarf star with a mass of about 80% and a luminosity of 70% that of the Sun. It's located 60 light-years away from Earth in the Carina constellation. The star is young, just about 1 billion years old. So it's not surprising HD 53143 is still surrounded by a disk of rock debris. As these rocks move, they're constantly colliding with each other, crashing on impact and turning into dust. Usually such disks are ring-shaped and resemble the Kuiper belt. But this one has a completely unusual crown or ellipse shape. And this is not the star's only strange and unique feature. During further observations, astronomers noticed that it has another inner disk, offset or tilted relative to the outer disk. The unusual thing is that the larger disk should gradually attract, destroy, and absorb the smaller one. Scientists have come to the conclusion that there's one possible scenario. If there's an object hiding in the system, its gravity might allow the disk to maintain distance. But this object would have to be at least a large exoplanet. To test their theory, astronomers will have to thoroughly search the entire vicinity of HD 53143 and look for an unknown space body, if there is one. To see the unusual behavior of another star, let's travel to the constellation Hydra. The star V Hydrae, located 1300 light-years from Earth, is nearing the end of its life. And recently, researchers noticed the dying star put on an incredible show, ejecting 6 rotating smoke rings and streams of plasma fireworks out into space. It sounds beautiful, but scientists weren't sure why the star was doing these things. It was once comparable in size to the Sun, but with age, it's become a red giant. More than 90% of solar mass stars follow this path in their evolution. But V Hydrae is the only one that emits gas rings similar to smoke rings in its final stages. And every few hundred years, a new ring appears around this carbon-rich star. Over time, it continues to slowly expand. All 6 smoke rings, which are about 2,100 years old, have long been hidden by a thick veil of dust around the star. They were very hard to find, but in 2022, the Atacama Large Millimeter Submillimeter Array Telescope detected the rings from very short radio waves of just 1 millimeter in length. And then, the telescope detected something even more intriguing. These are stunning hourglass-shaped gas bubbles. located in two opposite directions from the star. They were formed by the jet of gas that V Hydra ejected at enormous speeds. The plasma streams were picked up by the cosmic wind, which blew in two opposite directions at insane speeds of up to 800,000 kilometers per hour. This hurricane eventually turned the jets of gas into an hourglass shape. Large plasma outbursts occur about every 8 years. Such fountains of plasma have particularly stunned scientists. By all rules, there shouldn't be any. It takes remarkable energy to release such jets. So where does the dying star get that energy? One theory is that a sort of space vampire may be involved in the story, disguised as the star's good neighbor. There may be an invisible companion star orbiting close to V Hydra that affects this ejection mechanism. Part of the gas is sucked into space and forms an amazing hourglass-shaped structure. But the show of the dying V Hydra pales into comparison to what the star from the Eta Carinae binary system did. About 170 years ago, it exploded with enormous force, and for a time, it became the second brightest star in the night sky. And then a miracle happened. The star emerged from the fire in one piece. Astronomers discovered the light echo of this event in 2003 using telescopes at the Cerro Tololo Inter-American Observatory in Chile. As the investigation into the cosmic catastrophe progressed, the situation gradually became clearer. But scientists now have a theory and suggested that before the explosion there were not two, but three stars in the system. In the center of the system was a huge star, let's call it Star A. Next to it was a smaller star, B. And finally, on the outskirts, there was a very small star, C. When Star A got old, it started to lose its shell, and Star B began to hastily peel away layer upon layer of its neighbor, consuming its gas and matter. As a result, Star A was turned into a helium core. After that, the gravitational balance of forces in the system changed. Star B, swollen at the expense of the neighbor's shell, pushed A farther from the center, closer to Star C. Eventually, C crashed into B, and there was an explosion. It was very strong, but not enough to destroy the huge Star B. Instead, the small C star was blown into pieces. And so the system became binary, with stars A and B remaining. Scientists will continue to search for arguments in favor of this hypothesis using computer simulations and the new James Webb Space Telescope. J1407b is one of the weirdest planets scientists have discovered. Located about 434 light-years from Earth, this is Saturn on steroids. Studying this eerie world, astronomers struggle to measure its mass precisely, but it's believed to be around 10 to 40 Jupiter masses. J1407b is also a giant planet, much larger than the biggest planet in our solar system. What shocked scientists was the planet's ring system of enormous size. It consists of 30 rings, each the size of tens of millions of kilometers in diameter. According to rough estimates, the diameter of the entire ring system is 120 million kilometers. This is 200 times larger than the rings around Saturn. If Saturn had its ring system this big, it would dominate our night sky. But although this would have been a breathtaking view, it wouldn't last long. The rings would eventually become thinner as several satellites would form around the planet. But that's just the beginning. The universe has stored a lot more bizarre worlds for us. How can one planet be hotter than the sun and the other one larger than its star? How is there such a thing as a marshmallow planet? And what are planets? We've prepared a list of the most mind-blowing worlds for you. One of them is an exoplanet located 57 light-years away from Earth. Dubbed GJ504b, it's 4 times more massive but has just about the same size as Jupiter. The weird thing about it is, it's pink, quite an unusual color for a planet. So how did it get this color? The system is believed to be roughly 160 million years old, a newborn compared to our solar system. And because of the exoplanet's age, it's still changing and losing the heat of its formation, which gives it a dull magenta glow. But our universe doesn't only come in electrifying colors, it also has a lot of water-rich planets. A Neptune-like exoplanet, or the water world, has a mass of more than 8 Earths and a radius 0.24 times that of Jupiter. And although this alien world may seem promising due to its abundance of water, it's no Earth twin. The planet doesn't have a solid surface, and its atmosphere drastically differs from the one we have here. Because of extreme pressure and heat, it consists of water in a strange plasma form that behaves differently from that found on Earth. Despite the fact that the temperatures there reach 280 degrees Celsius, water on J1211738b doesn't have the usual vapor, liquid and gas phases, but rather a constant supercritical fluid form. So it has some properties of both liquid and gas, but overall it's neither and both all at once. Now let's move to the constellation Cygnus. There, about 650 light-years away, sits a scorching world, Kepler 70b. With a mass of just 0.44 Earths and a radius 0.75 times our planet's, this is one of the hottest exoplanets known to us. The planet star, Kepler 70, was once a main sequence star like our Sun, while Kepler 70b used to be a gas giant the size of Jupiter. But about 18.5 million years ago, the star went through its red giant stage. As a result of spending a significant amount of time inside its now dead star, a hot iron core of the planet is all that's left. Scientists think the planet is still evaporating, which could eventually make it even smaller. So how hot is it? Because Kepler 70b is 65 times closer to its star than Mercury is to the Sun, the temperature on this exoplanet reaches a mind-blowing 6,650 degrees Celsius. To compare, our Sun's surface is only about 5,500 degrees Celsius. So, if hell exists, it must be it. About 640 light-years away from us sits yet another scorching exoplanet dubbed Wasp 76b. But that's not the only thing the planet's known for. It also has a permanent dark side and molten iron rains. Discovered in 2016, it's nearly as massive as Jupiter. Since it's tidally locked to a star, the planet faces it at all times. The temperatures on the day side reach 2,350 degrees Celsius. This is more than enough to cause metals like iron to evaporate into the atmosphere. Additionally, the radiation that the day side receives is thousands of times more than our planet gets from the Sun. The dark side of Wasp 76b is almost twice colder. Due to this extreme difference in temperatures, intense winds form on this exoplanet. Because of that, the iron vapor from the hotter part of the planet is carried by the wind to the colder side, and as this vapor cools, it rains molten iron. That's odd enough, but not as odd as the planet dubbed PSR J1191738b. But what's so impressive about it? This exoplanet is 3,000 times larger than its host neutron star. What's more, it wasn't always a planet. It used to be a star in the past. But let's start from the beginning. The exoplanet orbits an incredibly dense and tiny neutron star about 20 kilometers across. Only 1 teaspoon of this star's material would weigh billions of tons on Earth. The star is also a millisecond pulsar that emits beams of radiation while spinning every 5.4 milliseconds. This is about 10,000 rotations per minute. The star isn't lonely. It has a companion planet about 40% the size of Jupiter, PSR J1191738b. At the same time, this alien exoplanet is more massive than Jupiter. So how come it's so small and yet so massive? This is because the exoplanet was once a star whose outer layers were stripped away by a much more massive nearby pulsar. This left a carbon remnant of a star that became a diamond world about 5 times the size of our planet. It now has a diameter of roughly 60,000 kilometers, and because the exoplanet's proximity to the pulsar is very close, the whole system could fit within the diameter of our Sun. Space seems to be crowded with weird exoplanets, and some of them have properties so bizarre you could hardly believe these celestial bodies exist. Dubbed Wasp 107b, this peculiar world has the density of cotton candy, which makes scientists revise their understanding of how gas giants form. While the exoplanet is about the same size as Jupiter, it's only 30 Earth masses, but Jupiter is 300 times as massive as our home planet. What's more, the core of Wasp 107b is just 4 times bigger than the Earth's core, while it should be about 10 times that of our planet's. Because of all this, Wasp 107b has an incredibly low density. In fact, it's like a marshmallow floating in space. So far, none of these worlds seem to be giving us any hope of colonizing them. But Gliese 581d could. Finding a planet that would be suitable for life is challenging itself, and it becomes even more so because of how far away most of them are. That's why Gliese 581d looks so promising. It sits well within 20 light-years from Earth and has a mass just about 6 times the Earth's. The exoplanet is in a habitable zone of its star, so the temperature could be right for liquid water on its surface. However, because it's tidally locked, one side of Gliese 581d is always warmer than the other. But it's not all that bad. Since carbon dioxide is abundant in the planet's atmosphere, it would keep the night side from freezing. While the Earth has its own regular day-night cycle and the majority of life forms here have adapted to live under such conditions, it's a big if the same could happen on Gliese 581d, given we colonize it one day. But if we do, the best idea would be to live in the region of habitability on the line that separates day and night, also called the Twilight Zone. The vastness of space is unimaginable, and Mass J2126 is living proof of that. This strange world was once thought to be a free-floating or lonely planet, but this celestial body isn't that lonely. It turns out that Mass J2126 moves through space along with a star, TYC 94869271. The weird thing is, both objects have been known to astronomers for years, but nobody saw the link between them. But then, scientists discovered the exoplanet and the star are both roughly 104 light-years from the Sun, which means they're connected. Later observations showed the planet orbits its star at a distance of 1 trillion kilometers. This is roughly 7,000 times the distance from our planet to the Sun. This makes it the largest orbital radius of any planet known so far. Interestingly, a result of such a huge orbit is that a year on this exoplanet equals about 900,000 Earth years. Now, let's get back to our solar system for a moment. The biggest planet here has 79 moons, so it seems logical exoplanets should have exomoons too. But for years, scientists haven't been able to find any, until now. Locating small cosmic bodies orbiting exoplanets is extremely hard. Nevertheless, astronomers have finally succeeded. But they didn't spot an exomoon. They found something even better than that. The first ever clear evidence of a moon-forming disk surrounding a huge distant exoplanet named PDS 70c. With the help of the ALMA telescope in Chile, scientists detected a disk in which satellites could eventually form, and its material is enough to make 3 of them, each about the size of the Earth's moon. For the first time in the history of astronomy, human beings could be observing how these small round worlds form in space, and not on a computer simulation, but live. The last exoplanet on our list is KOI 5AB, and what makes this one specifically unique is not its properties, but the system it's a member of. The planet about half the size of Saturn was first ignored because it was complicated and even considered science fiction. A decade later, the system named KOI 5 was given the scientific attention it deserved. It turned out astronomers stumbled across a triple star system. The planet revolves around star A, which has a relatively close companion, star B. They both revolve around each other every 30 years, but there's also a third gravitationally bound star, star C. And this one orbits stars A and B every 400 years. If we could somehow travel to this exoplanet and hover on the edge of this world's atmosphere with our spacecraft, we'd be seeing breathtaking and unusual things. The bottom view would be most probably filled with dark brown and grey clouds, and instead of one sun, you'd see two. One 17 times bigger than our star, and the other one quite smaller, and just about 0.5% as bright as our sun. But regardless of this, the fainter star would still glow 1,000 times brighter than the full moon here on Earth. No matter how unusual these alien planets are, there could be even stranger celestial bodies in our universe. So far, planets are usually hypothetical, but some scientists believe these could actually exist. If so, such mysterious worlds would form from the collisions of gas and dust particles surrounding black holes. These planets would also evolve at great distances from supermassive black holes, making their orbits million years long. The universe has no boundaries, not just in terms of distance, but also in terms of creativity. Now and then, astronomers discover mind-boggling space objects that broaden our limited imagination of the place we live in. It took us many years to discover all the planets of our solar system, and they're still surprising us with their properties. So who knows how much more eye-opening findings about the 5,000 known exoplanets are still ahead of us. Since the discovery of the telescope, astronomers have made huge steps into understanding the origin of the known cosmos. However, even after so many years, we're finding things in deep space that no one has seen before. On June 26, 2020, something mysterious occurred when 4 strange objects were identified by the radio telescope Australian Square Kilometre Array Pathfinder. These seem unlike any other astronomical objects ever seen before and ignited a spark of interest in the astronomical and space community. The first 3 objects were spotted in the depths of space using a pilot survey of a new project called the Evolutionary Map of the Universe, while the 4th object was retrieved in archival data which were collected by the giant meter-wave radio telescope in India and helped to confirm that the first 3 are not just lens anomalies. The object's distance from our solar system is still unknown, but one thing is certain: they're not located in the Milky Way's galactic neighborhood. Each object was calculated at around 1 arc-minute across, keeping in mind that, as seen from Earth, the Sun and Moon both have angular diameters of about 30 arc-minutes. The 4 unidentified objects are highly circular and with bright edges and look like distant ring-shaped islands. Because of their strange shape and peculiarity, they were characterized as odd radio circles, or ORCs for short. It seems that ORCs might have different origins. All of them were visible in radio wavelengths, but completely undetectable in visible light, infrared light, and X-ray light. 2 of them have galaxies at their center, which means that they might have been formed by them, while 2 of the ORCs might have some kind of interconnection or even the same origin, since they seem to be in close vicinity. There are several possible explanations of what those ORCs might be, but none of them seem to fit perfectly the object's specifications and characteristics. The astronomers already ruled out a description for those ORCs objects like supernovae remnants, planetary nebulas, circumstellar shells, star-forming galaxies, or even the possibility of gravitational lensing. But the EMU survey is just beginning, and astronomers expect it to reveal more unusual objects as the time goes by. Speaking of strange space objects and unsolved mysteries, we don't need to go very far to find a celestial body to draw the astronomers' attention. If we look inside our very own solar system backyard, we will find Hymia, a dwarf planet which is found in the Kuiper belt beyond Neptune's orbit. Why is it a strange planet, you're asking? Well, a day in Hymia lasts only 4 Earth hours, making it the fastest rotating large object of our solar system. Actually, it's rotating so fast that scientists argue that probably this is one of the reasons for Hymia's weird shape. This planet is not spherical, as you would expect any planet that respects itself to be, but instead looks a bit more like a football, since it's more or less twice as long in one direction as it is in the other. Hymia is 10 times smaller than Earth, with a radius of about 385 miles, and has 2 moons, Namaka and Hyaka. Due to its distance from the Sun, almost 43 times Earth's distance from it, one orbital period is approximately 282 Earth years. But a recent discovery made Hymia an even more interesting space object. It appears that this hobbit-sized planet's equator is encircled by a 43-mile wide ring of debris located about 620 miles from its surface. This discovery, in combination with Hymia's unusual features and the trajectories of several Kuiper Belt free-roaming objects, gave the astronomers a very good indication of what happened with this dwarf planet. According to a mathematical model, it looks like that a large Kuiper Belt object smacked at some point the younger and larger Hymia. The dwarf planet's ring and moons seem to be fragments of that collision, which also seems responsible for its fast-paced rotation. This is still a theory regarding Hymias, but seems to fit the bill very closely. If we go a bit further, just a mere 20 light-years away from us, we can find the planet SIMP 0136 on the constellation of Pisces. This planet has given the scientists a good head-scratching, since it was discovered to have such a strong magnetic field that in an imaginary arm wrestling competition with Jupiter, SIMP 013 would win as if it was wrestling against an ant. You see, it has a magnetic field more than 200 times stronger than Jupiter's, which, as a reference point, has 16 to 54 times stronger magnetic field than the Earth. The planet forms the most spectacular auras, and astronomers don't really know the reason behind this, but hopefully we'll know in the near future. Furthermore, this planet is of even greater interest to the scientists because it's exactly at the boundary between a planet and a brown dwarf, or as it's also called, a failed star. This characterization means that this planet is quite large, at about 12.7 times the mass of our solar system's biggest planet, Jupiter, but not quite large to fuse hydrogen in the way stars do. Under further investigation, it was discovered that SIMP 0136 is actually a youngster brown dwarf of only 200 million years of age and is traveling the cosmos on its own without an orbit around a star. The scientists hope that SIMP 0136 will give them answers regarding the magnetic dynamo mechanisms of planets beyond our solar system, and that with the help of their radio telescopes, they'll discover more planets with such distinctive auras. One of the greatest problems in cosmology is that of dark matter. Well, this has nothing to do with black particles or any sinister type of material that destroys celestial objects. Dark matter, or as we initially called missing matter, is a type of material that cannot absorb, reflect, or emit light and cannot be detected by observing electromagnetic radiation. This means that it's extremely difficult to detect, and astronomers can only identify it by observing the gravitational effects that it has on other visible objects. One of the leading theories is that dark matter is made up of some new kind of subatomic particle that we haven't discovered yet. Even though undetectable, dark matter is extremely essential since it acts as the glue that keeps the visible matter of all known galaxies together. Astronomers estimate that dark matter accounts for 85% of the matter in the universe and about 25% of its total mass energy density. This is a lot, and it means that dark matter exists almost everywhere. Keep that thought for a second. In 2018, a team of astronomers announced that they have discovered the first known galaxy which contained an amazingly low amount of dark matter, almost zero. Its name? NGC 1052 DF2, or the more convenient DF2. This 10 billion years old galaxy is 6.5 million light-years away from our solar system and is more or less the same size as our Milky Way, but contains 200 times fewer stars. Because of that, DF2 is classified as an ultra-diffuse galaxy, meaning it has low luminosity and detectability. How did the scientists find out that DF2 has very little levels of dark matter? Well, we said that dark matter affects the movement of planets and other celestial objects. We know it's there because without it, there's no way of explaining the trajectories and velocities of planets and stars. This did not seem to be the case with DF2. And several star clusters inside it are moving at speeds in line with only the mass of the observable normal matter. After close inspection, it seems that DF2 contains at best 1/400th the amount of dark matter that astronomers had expected it to have. One other reason that constituted DF2 as an oddball galaxy is its shape. It doesn't have a noticeable central region or any of the characteristics of a spiral galaxy such as spiral arms or a disk. It doesn't look like an elliptical galaxy either, and there's no evidence that DF2 has a central black hole. just a stellar halo and several globular clusters. Everything about this galaxy seems strange and cannot be explained by any of the modern theories. The same team of astronomers quickly discovered another galaxy that shares the same bizarre nature in terms of low concentration in dark matter, with the name NGC 1052 DF4, or DF4 for short. Every galaxy we knew about before has dark matter, so you understand that these kinds of discoveries are a breakthrough that might help us understand the way dark matter-less galaxies work and get a firmer grip of the mysteries of the cosmos. In 2018, a dwarf galaxy nicknamed Bedin 1 was discovered in our Milky Way's space backyard, just 30 million light-years away from our doorstep. As a reference point, the whole observable universe is a humongous 93 billion light-years across, so you understand that this is extremely close to us. Bedin 1 is characterized as a dwarf spheroidal galaxy because of its small size, low luminosity, lack of dust, and its old stellar populations. However, this newly found galaxy is special in so many ways. First of all, it's tiny, just 3,000 light-years from side to side. In order to grasp how small this is, think that the Milky Way's famous spiral disk has a diameter of 100,000 light-years. Furthermore, Bedin 1 is approximately 2 million light-years away from any other bigger galaxy, which makes it the most isolated dwarf galaxy known to man. Lonely isn't a bad thing in the universe. It means that the dwarf galaxy hasn't had any interactions with other galaxies. But the most important is that Bedin 1 is calculated to be as old as the universe itself, more or less 13 billion years of age. And due to its isolation from any other galaxy, Bedin 1 is the equivalent of a living fossil from the early days of the universe. Who knows how many secrets this grandpa of a galaxy hides from us? Only time will tell. When it comes to deep space unanswered mysteries, one thing is for sure: we still have many spectacular things and objects to discover. Based in Australia, the International EMU project has a team of over 300 scientists from 21 countries. The job of this team of scientists is to survey the entire southern sky as far as 30 degrees north. EMU plans to peer into parts of the universe with the ASCAP telescope, which can survey large swathes of the sky very quickly and look where no other telescope has looked before, and create a higher resolution radio map of objects in the southern sky. But now imagine for a moment you're one of the scientists using this telescope when suddenly you spot something so strange that you end up calling it Object WTF. This is exactly what happened to radio astronomer Anna Kapinska in September 2019. While browsing through observations made by the EMU project using the revolutionary new ASCAP telescope, she noticed a weird shape that looked like a ghostly circle of radio emission hanging out in space like a cosmic smoke ring. A few days later, another team member of EMU, Emil Lenk, found a second ring, even spookier than the last. And despite eliminating all the obvious explanations of these strange objects in their latest research, the team at EMU are still working to explain where they came from. From the very beginning, the team of astronomers at EMU predicted exploration of the unknown would lead to unexpected discoveries, but they didn't expect to see an anomaly like the mysterious ORCs so quickly, and the discoveries were a shocking surprise for the team. Although our scientists have a decent understanding of the workings of our universe, they've only begun to scratch the surface. To put it into perspective, some years ago, astronomers pointed the Hubble Space Telescope at a dark speck of sky so small it could be covered by Abraham Lincoln's eye on a penny, held at arm's length. With that tiny area of the dark sky, they discovered 3,000 points of light, each galaxy comprised of an average of 100 billion stars. In this vastness of space, only 4 of these ORCs have been found. They don't really know what they are, exactly how far away they are, or even how they were formed. At first, the scientists thought the discovery was generated by a software error, but soon they were confirmed to be real, as independent confirmation was provided using the Australia Telescope Compact Array and the Murchison Wide Field Array. The only thing scientists have been able to do so far is rule out possibilities of what the ghost circle could be. they can be seen in the radio spectrum. In fact, when other types of telescopes were pointed towards them, the odd radio circles were not visible at all. None of the ORCs has any obvious optical, infrared or X-ray counterparts, which has made life very difficult for those studying them. ORCs 1 to 3 were discovered by visual inspection of the images from the EMU survey, but ORC 4 was found in archival data taken with the giant meterwave telescope all the way back in March 2013. This means that even before the ASCAP telescope, there is a strong possibility that astronomers have been staring at these objects for years without ever detecting them because of their inferior instruments. When it comes to the ORCs, the biggest problem facing astronomers is that circular features are regular occurrences in radio astronomy. They usually represent a spherical object such as a supernova remnant, a planetary nebula, or a star-forming galaxy. They may also arise from imaging artifacts around bright sources caused by calibration errors. However, ORCs do not seem to correspond to any of these known types of object or artifact. The 4 ORCs are very similar in nature. They all display a strong circular symmetry, and their diameter is about 1 arc a minute, which is about 1/60th of a degree. But despite their similarities, they differ enough to confuse astronomers even more. 2 of them have a galaxy near the center of the radio emissions, which are in the visible spectrum, while the other 2 don't. Also, 3 of them consist of a party-filled ring, while ORC 3 seems to be a uniform disk. There's another puzzling thing about them. 2 are very close together, implying that these 2 ORCs have a common origin. This is not the same for ORCs 1 and 4, implying they are occurrences based on 2 very separate events. When faced with such challenges, the scientific method is to slowly and methodically eliminate possibilities until scientists can claim that they found something uniquely new. That's exactly what the EMU team recently completed. And in November 2020, they published their findings in a research paper for the Astronomical Society of Australia. Here's what they found. The first possibility they eliminated was the ORCs being a supernova remnant or SRN. SRNs are structures resulting from the explosion of a star in a supernova. The remnant is bounded by an expanding shock wave and consists of ejected material expanding from the explosion. The scientists studying the ORCs found that the probability of one of them being a supernova remnant is only a 0.055% chance, and that the probability of the other 3 being SRNs is 2.1 times 10 to the power of -5%. Therefore, it's unlikely that the ORCs are remnants of supernovae. The second possibility was these bizarre radio circles were galactic planetary nebula, or planetary nebulae, that can also appear as diffused disks of radio emissions just like ORCs. They form at the end of the life of a star of intermediate mass anywhere between 1 and 8 solar masses. In fact, our Sun will also form a planetary nebula at the end of its life cycle. However, the radio emission of PNE is generated by thermal emissions and therefore expected to have much higher spectral index than those measured for the 4 odd radio circles. In simple terms, it means that the proportional relationship between the amount of power radiated through a given area and the frequency of the radiation is much lower in the case of an ORC, and thus they could not be classified as PNEs. The EMU team also eliminated other possibilities such as the ORCs being part of a star-forming galaxy or a ring galaxy viewed front-on. All such galaxies are bright and optical wavelengths, which contrasts with the lack of measurable optical emission from the ORCs. They also cannot be considered part of a double-lobed radio galaxy or a bent-tail radio galaxy for the same reason. The other possibility is that the circles are an Einstein ring, which is a gravitational lensing of background sources that produce arcs of emission. If a source, lens, and observer are aligned, then the lensed image can take the form of a so-called Einstein ring. But in the case of the ORCs, it's unlikely that such a lens would be sufficiently symmetric and perfectly aligned with the background source to produce the observed circular symmetry observed in an Einstein ring. They've also put an end to theories that these ORCs could be other astronomical objects, such as gravitational termination shock or a cluster halo, both of which are phenomena observed after a neutron star goes supernova. Most astronomical research is aimed at refining our knowledge of the universe, or testing theories. Very rarely do astronomers get the challenge of stumbling across a new type of object, which nobody's seen before, and to try and figure out what it is. The mystery behind these new, ghostly circles continue. The question astronomers have to continually ask themselves is whether these ORCs are a completely new phenomenon, or something they already know about, but viewed in a weird way. And if it really is completely new, how does that change our understanding of the universe? So what do you guys think? Do you believe the scientific community will take years before they can pinpoint the origins behind the odd radio circles, just like the fast radio burst research? Or will they solve this new astronomical mystery relatively quickly? Let us know in the comments. When a star several times larger than our Sun is on its last legs, it goes out by generating the most spectacular blast ever observed by the human eye, a catastrophic hypernova. This phenomenon is so bright that it can outshine an entire galaxy of hundreds of billions of stars, and is so powerful that it can generate more energy in a single day than our Sun will generate in its entire lifetime. In fact, a hypernova is the most powerful explosion in the galaxy, coming second only to the Big Bang. Roll up your sleeves and put on your smart glasses, because we're going to crack together the science behind hypernovae. In order to do that, we first need to dissect its smaller brother, the supernova. There are two ways this kind of smaller explosion can be formed. The first one can occur in systems where two stars orbit one another in a binary system, and the other comes from a white dwarf. When a smaller-sized star runs out of the fuel in their core and are about to die, they eventually turn into white dwarfs. With no source of internal energy, their gravitational collapse causes them to become extremely dense, sometimes reaching densities 200,000 times that of the planet Earth or more. As a reference point, a typical white dwarf is half as massive as our Sun, yet only slightly bigger than Earth. Their fate is to slowly cool down until they're completely cold, at which point they become black dwarfs. In a binary solar system where two stars are so close together that they orbit each other, one carbon-oxygen white dwarf can start pulling matter from its brother star, and it becomes more dense as mass piles up. When it exceeds a critical point of density, the star inevitably detonates in a fantastic bang, forming a supernova. The second type of supernova is formed during the death of giant stars. When a star at least 5 times the size of our Sun is about to die, it'll go out in a massive cosmic explosion. During their whole lives, all stars survive because of the delicate equilibrium of two powerful forces: the star's own gravity, which fights to compress it into an extremely tight ball of mass, and its opposite, the star's outward pressure generated from the nuclear fuel burning in its core. When a star burns all its nuclear fuel, gravity starts winning, and this million-year-long battle eventually ends up with a catastrophic collapse. Enormous shock waves are generated at such a quick pace that the outer part of the star explodes, generating a bright and powerful explosion. A typical supernova may shine with the brightness of 10 billion suns and generate 10 to the 44 joules of energy. Astronomers estimate that, on average, about 1 or 2 supernovae explode each century in our galaxy. The last time Earth felt the effects of a supernova was about 1.7 to 3.2 million years ago, but thankfully, the explosion took place 325 light-years away, which is 6.5 times farther than the danger zone of 50 light-years. Earth, however, was still affected to some degree. What is the case with hypernovae, though? Even though there are a few differences in the science behind them, a very simplistic definition would be that a hypernova is a supernova on steroids, generating an explosion which is 100 times more powerful. Hypernovae are so powerful that the energy they release in the first few seconds of the explosion can be 10 to the 16 to 10 to the 19 orders of magnitude greater than that of the Sun. This means that a single hypernova can supply our Earth's energy needs for 1 billion years, if not more. Astronomers think that they have a good handle on what causes an average supernova, but this is not the case for hypernovae. You see, the latter are extremely rare, and we only have estimated a few dozen of them over the past few decades. The experts are still not sure what causes a hypernova to be so colossally more impactful. We're going to show you the 3 leading scenarios for hypernovae formation. In the first case, the collapsed star or collapsar model states that when a fast-spinning massive star that is at least 15 times the Sun's mass depletes all its nuclear energy, then its supercompressed core is crushed by the star's gravity and folds in on itself, giving birth to a black hole. Under the right conditions, the same phenomenon might occur to a smaller scale star that undergoes a supernova explosion if much of its ejected mass collapses back onto the remnant crushed core. The uncountable tons of material around the star will start swirling and flowing into the black hole, and 2 jets of material will start blasting away from the black hole at near the speed of light. These jets can last for several seconds and create long-duration gamma-ray bursts, making up for a magnificent light show for anyone looking at them through a telescope thousands of light years away from it. The second scenario supports that in the center of a huge star, vast amounts of electrons and positrons, known as particles and antiparticles, find their lost halves and form dangerous gamma radiation. The opposite procedure happens as well, and this cycle goes on forever inside the star. Under special circumstances, this cycle might get out of balance just enough so that too many pairs of particles can form to the point that the star cannot keep its core under control, and it pops its guts out, forming a hypernova. The last scenario is very similar to the twin star solar systems for supernovae. If the circumstances are exactly perfect, and one of the stars explodes in such a spot and speed that releases its material exactly on its neutron star brother, then the latter becomes a very dense and unstable neutron ball, and an explosion might get triggered. It's a scaled-up supernova explosion that eventually might form a magnificent show, a hypernova. Scientists are still not sure which of the 3 mechanisms is more common, but if we know one thing, is all hypernovae are massively devastating and destructive. But how dangerous is a supernova? It wouldn't be a surprise if we told you that a typical supernova, and let alone a hypernova, are capable of constituting a planet like Earth uninhabitable if the event happened very close to our solar system. Imagine that there is a gigantic star 10 times larger than our Sun that would explode, forming a supernova only a mere 25 light-years away from our poor Earth. What would happen to us? Well, the explosion will trigger a blast of fast-moving, invisible neutrinos towards our planet. These are very small, slippery particles that carry vast amounts of energy that were originally trapped between the dying star's core and its atmosphere. They would arrive at high speeds, a tad slower than the speed of light, but thankfully, they're the least harmful of all the elementary particles that we know of. The real problems will start a few hours later, when an immeasurable number of photon particles would start arriving at Earth's atmosphere. An observer would be able to see the star's breathtaking explosion with a naked eye from our planet's surface. It would be like a small blinding spot in the sky, much smaller than our Sun, but definitely highly dangerous. In addition to the visible light, the exploded star would spit X-rays, gamma rays, and hard ultraviolet radiation into our atmosphere, completely destroying the Earth's ozone layer. All life as we know is fueled by sunlight, and by destroying the ozone layer, which is our planet's sunglasses, there would be unimaginable changes. The less ozone there is, the more UV light reaches the surface. Just a 10% increase in ground-level UV can be devastating to some organisms, such as phytoplankton. And since these organisms form the basis of oxygen production on Earth, and are the basis of all marine food chains, any significant disruption to them could trigger a mass extinction. But for such an event to happen, the supernova explosion must occur less than 50 light-years away from our planet. Additionally, any supernova closer than 1,000 light-years could still potentially have some kind of low impact on Earth's biosphere, but to a much lower degree. A hypernova, though, can be fatal even from distances of 10,000 light-years away, because of its jets that spew gamma rays at speeds close to the speed of light. However, the jet must be directly pointed our way in order to be fatal. The closest burst on our record, which is known as GRB 031203, was 1.3 billion light-years away, which, as you understand, was completely harmless. But since distances in space are extremely vast and most giant stars are millions if not billions of light-years away from us, there are not that many stars that we need to worry about that might die anytime soon. At present, there are no supernova candidates close to our solar system which are less than 50 light-years away, and only 6 near-Earth supernova candidates within 1,000 light-years. IK Pegasi, which is the closest candidate giant star at 150 light-years away from us, is estimated that by the time it could potentially go boom, our solar system will be at a safe distance due to the relative trajectories we're both traveling across space. Many experts seem to worry in the past about Betelgeuse from the Orion constellation, which is a very old star, 15 times the size of our Sun. However, it's been proved that even with the most pessimistic scenarios, there is a possibility of less than 0.1% that we're going to experience the supernova explosion of that star during our lifetimes, and most probably it won't do any kind of direct damage to Earth with ejected material. When it comes to radiation, such a supernova explosion might cause some effects on Earth's environment, but since it's too far away to harm our atmosphere, there'll only be a minor impact on life on our planet. As a little bonus, we want to share an interesting hypernova story. In 2016, a team of astronomers spotted an unusually bright object in the sky, only to discover that they somehow stumbled across the most powerful supernova on record. The ASASSN 15LH, which is located in a galaxy 3.8 billion light-years away from us, was actually so powerful it outshined an average supernova by almost 200 times and our Sun by 570 billion times. As a reference point, if you could somehow pull all 100 billion stars in our Milky Way galaxy into a blender, then pour the mix into the biggest sphere in existence, the ASASSN 15LH would still manage to shine 20 times brighter than it. Astronomers believe that they'll possibly never see a supernova this bright ever again. And let's hope that even if we're going to witness even a small-scale supernova, that it would be at such a distance that we could enjoy the fireworks and learn more about this magnificent phenomenon, but without the harm of any damage to our solar system. So, now you've seen how hypernovae are created and how deadly they are. Do you think we should be afraid of them? Let us know in the comments below. And if you enjoyed the video, give us a like, subscribe, and turn on the notifications to be the first to know when a new video arrives. Thanks for watching.